In previous lecture we discussed the locus of a point and the equation of locus. So problem based on that we solve from exercise 5.1. So see the first question. Question number 1. If A of 1 3 and B of 2 1 are points, find the equation of locus of point P such that PA equals to PB. So here we have to consider coordinate of point P, that is coordinate of locus of point P. So we write here in solution first, let P of xy be any point on the required locus. Then according to given condition we write here PA equals to PB. So we take square on both sides. So we write here PA square equals to PB square. Now we apply distance formula for point P and A and a distance formula for point P and B. So in left hand side we use concept x2 minus x1 bracket square plus y2 minus y1 bracket square, that is distance formula. So we write here we consider x2 as x, y2 as y and x1 as 1, y1 as 3. So we write here x minus 1 bracket square plus y minus 3 bracket square. For right hand side we consider x2 y2 as xy and x1 y1 as 2 1. So we write here x minus 2 bracket square plus y minus 1 bracket square. So we have to simplify this. So we simplify this first bracket. So we have to apply a minus b bracket square form for this x minus 1. So we write this as x square minus 2x plus 1. For this y minus 3 we write y square minus 6y plus 9. Similarly for right hand side we apply a minus b form for this first bracket. So we write here x square minus 4x plus 4 for this first bracket, and for this second bracket we write y square minus 2y plus 1. So if you observe, this x square get cancelled with this x square, this y square get cancelled with this y square. Then we collect the terms of variable x, terms of variable y and constant. So we write here minus 2x minus 4x, then plus 1, this plus 1 get cancelled here, so we not write in this step. Then this minus 6y, and in right hand side this plus 4 and minus 2y. So we add the term, that we collect first terms of variable x, then terms of variable y, then constant. So we transfer this minus 4x to left hand side. So write minus 4x as plus 4x in left hand side, this minus 2x as it is, this minus 6y as it is. We transfer this minus 2y to left hand side. So we write here plus 2y, then this plus 9. After transferring this plus 4 to left hand side we write minus 4. So we write here, after simplifying, 4x minus 2x, that is plus 2x, plus 2y minus 6y, that is minus 4y, 9 minus 4 which is plus 5 equals to 0. So in this way we obtain the equation of locus of point P such that PA equals to PB. So we write here, this is the equation of locus. Now see second example, question number 2. Question 2. Coordinate of A are minus 5 2 and coordinate of B are 4 1. Find the equation of the locus of point P which is equidistant from A and B. Now question is same as question number 1, but here instead of writing the condition directly PA equals to PB, here that condition given in verbal form, P is equidistant from A and B, that means PA equals to PB. So we write here in solution, let P of xy be any point on the required locus. So P is equidistant from A and B, this is given condition. So we write here PA equals to PB. So squaring on both sides we write this as PA square equals to PB square. So again apply distance formula for PA and PB. So we write here, in left hand side we write x minus 5, so minus minus get plus 5, so write x plus 5 bracket square, then y minus 2, so we write here y minus 2 bracket square. That means here we apply x2 minus x1 bracket square plus y2 minus y1 bracket square, that is distance formula. Similarly for right hand side, so for PB we write x minus 4, then y minus 1, so right here x minus 4 bracket square plus y minus 1 bracket square. So simplify this first, so we write the simplified form for each bracket. So x plus 5 bracket square we write x square plus 10x plus 25, y minus 2 bracket square we write y square minus 4y plus 4, and x minus 4 bracket square we write x square minus 8x plus 16, plus for y minus 1 bracket square we write y square minus 2y plus 1. So again this x square get cancelled with this x square, this y square get cancelled with this y square, then see the remaining terms we write here plus 10x plus 25, then minus 4y plus 4, because x square y square get cancelled. Similarly in right hand side this x square y square get cancelled, so we write minus 8x plus 16 minus 2y plus 4. Now we collect the variable x, variable y and constant in one side. So we write here plus 10x, after transferring this minus 8x to left hand side we write plus 8x, then minus 4y we keep as it is, transfer this minus 2y to left hand side we get plus 2y, then 25 plus 4 we write 29, here 16 plus 1 which is 17, after transferring to left hand side we write minus 17. Now add these terms, so 10 plus 8x we get 18x, minus 4y plus 2y we get minus 2y, 29 minus 17 we get plus 12. So you can take 2 common from each term. So write here 2 in bracket 9x minus y plus 6 equals to 0. We know that 2 is not 0, that means value of bracket is 0. So we write here 9x minus y plus 6 equals to 0. So this is the required equation of locus. So right here this is the equation of locus. Now see question third. If a of 2 0 and b of 0 3 are 2 points, find the equation of the locus of point P such that AP equals to 2 times BP. So instead of giving equidistance, here condition is AP equals to 2 times BP. So with the help of this condition we find the equation of locus of point P. So we consider coordinate of point P first. So write in solution, let P of xy be any point on the required locus. Here condition is AP equals to 2 BP, 2 times BP. So we square on both sides. So after squaring both sides we write square of AP as AP square, square of 2 times BP as square of 2 and square of BP. So write square of 2 as 4, square of BP as square of BP as BP square. Now substitute the value of AP and value of BP by using distance formula. So here this xy we consider as x2 y2 and this coordinate of point A as x1 y1 for left hand side, and for right hand side this coordinate of point B as x1 y1. So see here we write here value of AP square as x minus 2. So here coordinate as x minus 2, then y minus 0. So by distance formula we write x minus 2 bracket square plus y minus 0 bracket square equals to 4 in bracket. So this 4 is multiply for this BP square, so we use here square bracket. Then by using distance formula we write x minus 0 bracket square plus y minus 3 bracket square. Now simplify this. So we simplify this first bracket. So apply here a minus b bracket square form. So write x square minus 4x plus 4, y minus 0 we write y. So y square we write here. Then in bracket x minus 0 we write x. So we write here x square. Then y minus 3 we simplify it. So y square minus 6y plus 9. Now multiply each term by 4 to right hand side. So we multiply each term. So we write 4 into x square as 4x square, 4 into y square as 4y square, 4 into minus 6y as minus 24y, 4 into 9 as plus 36. Now we shift all the terms of left hand side to right hand side. So we write here in left hand side we write 0. So 4x square minus x square we write 3x square, 4y square minus y square we write 3y square. Then we transfer this minus 4x to right hand side. So write this as plus 4x. Then this minus 24y as it is. Then we transfer this 4 to right hand side. So this 4 becomes minus 4 in right hand side. So 36 minus 4 we write plus 32. So instead of writing 0 in LHS we write in RHS. So we write this as 3x square plus 3y square plus 4x minus 24y plus 32 equals to 0. This is the required equation of locus. So we write here this is the equation of locus. Then see next question, question number 4. If a of 4 1 and b of 5 4, find the equation of locus of point P if pa square equals to 3 times pb square. So we write here in solution point P first. So write let P of xy be any point on the required locus. Now condition is pa square equals to 3 times pb square. Again we use the distance formula for pa and pb. So write here x minus 4 bracket square plus y minus 1 bracket square. In right hand side 3 in square bracket we write x minus 5 bracket square plus y minus 4 bracket square. So we write here y minus 4 bracket square. So first we simplify all the brackets. So write for x minus 4 bracket square as x square minus 8x plus 16. For y minus 1 bracket square we write y square minus 2y plus 1. And in square bracket for right hand side we simplify this x minus 5 bracket square as x square minus 10x plus 25, and this y minus 4 bracket square as y square minus 8y plus 16. Now we have to multiply each term by 3 to right hand side. So we write here 3 into x square as 3x square, 3 into minus 10x as minus 30x, 25 into 3 which is plus 75, 3 into y square as 3y square, minus 8y into 3 that is minus 24y, then 16 into 3 which is plus 48. Now we transfer all the terms of left hand side to right hand side. So write in left hand side 0, then 3x square minus x square we write plus 2x square, 3y square minus y square we write plus 2y square. Then we write this terms of x. So minus 30x, when we transfer this minus 8x to right hand side we get plus 8x. So minus 30x plus 8x we write here minus 22x. Then minus 24y, this minus 2y after transferring to right hand side we get plus 2y. So minus 24y plus 2y we get minus 22y. Then we write this 16 plus 1 that is 17, then 75 plus 48, and after transferring this 16 plus 1 17 to right hand side we get 106. So taking 2 common from each term. So first we write left hand side in interchanging form, that is in right hand side. So we write this as, now take 2 common here. So taking 2 common, we write 2 in bracket x square plus y square minus 11x minus 11y plus 53 equals to 0. So we know that 2 is not 0, that means bracket is 0. So the required equation is x square plus y square minus 11x minus 11y plus 53 equals to 0. This is the required equation of locus.